Okay, so in our previous segment, we learned how to add vectors together. So that if you had an arrow that went in this direction, and then you had another arrow that went in this direction, we found out that you could add those two arrows together and that you would end up with another arrow. And let's say that that arrow is going to be this arrow, and it's going to be this one plus that one. So head to tail, take this one and put it at the head of that one, or take this one and put it at the head of that one, and then you would end up with this arrow. But what would happen though if we add a third arrow to this thing so that these two arrows cancel out? Okay, so that the total force acting on the system would be equal to 0. So what would happen if we did that? So then that's going to be called static equilibrium. If all of the forces acting on the system total up to 0, then it's going to be in static equilibrium. Now, when it's in static equilibrium, don't get the idea that it doesn't move. It could move, it's just it's going to move at a constant speed. So do you remember that if the acceleration is equal to 0, then that means that the final speed is equal to the initial speed. So if something is in static equilibrium, it actually could be moving, it's just it's going to be moving at a constant speed. Now, most of the time when we do statics problems, it's not going to be moving, but it could be. So let's take a look at this picture here, which is an example of static equilibrium. We've got two forces that are going up. So those are the ropes that are holding up that beam, and then on the beam is going to be a painter and then a paint bucket. So we've got two forces that are being pulled up. It's got to be in static equilibrium, so that means the sum of the forces must be equal to 0. So that must mean that when we add together the force, which represents the weight of the beam, and then the force that represents the weight of the paint bucket, and then the force that represents the weight of the person, if you add these three together, it's got to equal the opposite of these two up here. If it's in static equilibrium, the sum of the forces has to equal 0. So here's how we do it. We are going to set force equal to 0. And then we say, well, what are the forces going up? Those are going to be positive. So we're going to have 700 plus 500. And then what are the forces going down? Well, that's going to be the 600, but notice we give it a negative sign because it's down, and then a negative 100, and then we don't know what the board is. So we just say F for board, and then we solve it, and then it turns out that the force of the board had to have been 500 newtons down. So that's how you're going to solve a statics problem. Now, you could also even do problems where the forces are not parallel to each other. That can be done. We do it in a more advanced course where we also take into account the torques that are acting on the system. So you're definitely not going to do that on the exam. Okay, let's take a break. When we come back, we'll talk about different kinds of forces.